In this video, I will show you how you can evaluate a design using netting theory in TaniqWind Pro. During this demonstration, I will show you how you can evaluate the stresses and strains in a cylindrical part of your product. For this demonstration, I will be using the shown pressure vessel design, which consists of helical and hoop layers. We can see that the product is built up with over 60 layers. We start by opening the netting theory evaluation panel by going to the Evaluate section in the Analysis tab and pressing the Netting button. In the panel, we can set the Z position at which we want to calculate the strain and stresses. Please note that the selected Z position should be at the cylindrical part of the innermost profile. We will start at Z equals to 0, which is the center of the product. In the results section, we can fill in the design pressure for the product in the design pressure box. In the burst pressure box, the calculated burst pressure can be found after computation. For these computations, the used materials for all layers should have an orthotropic material assigned. To calculate the burst pressure, the XT1 or tensile strength in the one direction must also be assigned to the used materials. If we set the Z position to 0 and the design pressure to 1050 bars and press the compute button, we can see that the burst pressure is calculated to be almost 1100 bars. In the plot area, we can see the strain per path in the blue columns together with the maximum allowed strain plotted. In this plot, we can see that the strain per path stays under the maximum allowed strain. If we now set the Z position near the end of the cylinder at Z equals 275 and recalculate the strain and stresses, we can see that the burst pressure is around 630 bars. Now, the strain per path exceeds the maximum allowed strain by more than 1 percentage point. We can now select the stress plot, where we can see that the material would need to withstand a stress of 4.5 gigapascals. It should be noted that the netting theory evaluation is a basic analytic tool which may not be as accurate as more extensive methods like FEA. If you want to know more about the FEA export capabilities of TaniqWind Pro, you can find the Abaqus and HyperWorks export videos on the TANIQ YouTube channel. This is the end of the netting theory evaluation demonstration video, where I've demonstrated how you can evaluate your made design using netting theory in TaniqWind Pro. If you're interested in other highlighted videos, these can be found at the TANIQ YouTube channel.